Okay, this is Mr. Weideman, and I'm here to help you with one of your problems in the University of Texas Quest, forces in accelerated motion. This particular problem is called the workers' compensation problem, and this problem is actually fairly easy to solve if we just consider it as an Attwood's machine. Now, there's two major portions of these problems. One, the yanker gets flies up to the top of the building because the weight of the barrel hits the ground, the bricks spill out, and the worker falls back down. All right, so let's look at the first scenario. Okay, so the first scenario is he's got this barrel, which has some mass, and he filled it full of bricks, which has some mass. All right, so I've got a total mass up here of M bricks plus M barrel, all right, up here. And then he climbs down to the bottom, he undoes the rope, and his mass is far less than this mass. And all of a sudden I have this Attwood's machine. So I have the weight of the bricks in the barrel. That's one force on the Attwood's machine. And then I have the weight of the person. That's another force on the Attwood's machine. So these types of problems are easiest to consider when I consider this system as a whole. So I have two major forces acting on this system. Now, this has much more mass than this, so this is my assumed direction of acceleration. So that's my direction of motion, so I'm going to make that positive. Any sorts of force problems, that's always best. You assume a direction of motion and make that positive. Okay, so I'm going to have the mass of the barrel plus the mass of the bricks in it times G. That is going to be opposed on the other side of the Attwood's machine by the mass of the person times G. And then that is going to equal to the mass of the entire system, bricks, barrel, person, times the acceleration of the entire system. So I can solve for acceleration. Once I have acceleration, now I have a bit of a kinematics problem. Okay, they're telling me that the time to go up is known. And then it asks, how high is the building? So we're looking now for this distance, h. Okay, we could probably solve this. Once we have acceleration, there's a number of ways to do it. We can say our height is distance in the y, v initial times time, plus 1/2 at squared. All right, he's starting at rest. Here my acceleration, I can plug in. My time is given. So then I can easily compute the top, or how high the building is. So in the next video, I'm going to talk about then what happens on the way down.